We know academia, for such a long time, we emphasize knowledge, creation, and pass to students, right? This continue, of course, to be one major pillar. But now in the Doerr School, there's another pillar we are building up. How to generate solutions to impact the real world, in addition to knowledge creation. By the way, startup world, the high point is so few, but low point are a lot.
Yeah, right.
That's a norm. A lot of low points,
Yeah.
very few high points. So that's experience.
Welcome to the Stanford Ecopreneurship Podcast, where we explore how university research and innovation move beyond the lab to shape real-world climate solutions. I'm your host, Sam McClure. This is our Academic Innovator series, and today's guest is Professor Yi Shui, a pioneering scientist, entrepreneur, and academic. Yi has spent 2 decades at Stanford, working on next-generation batteries, air and water purification, and carbon capture. He is the faculty co-director of Stanford Ecopreneurship and a founding director of the Stanford Sustainability Accelerator. His research has been translated into several companies, including Amprius and 4C Air. We discussed why Yi finds nanotechnology so exciting, the global transition to sustainable energy, and what academics can learn from becoming entrepreneurs. At the heart of Yi's work is a belief that science should serve society and that universities can be platforms for action. Yi, thanks so much for joining us today.
It's my honor.
Awesome. We have a lot to talk about, and we only have an hour, so we'll start maybe at the very beginning. I'd love to learn a little bit more about your upbringing in China, because that's where you did the early part of your life and your early academics before you came to the States. So could you describe maybe a little bit about your childhood? Were your parents academics? What did they do?
First 22 years of my life in China. I was growing up in China. Until I finish undergraduate degree and then come to US for graduate school and stay since. So I've been in the US longer than the time I was in China. So I've been in the United States for 27 years now.
Wow. Yeah.
My parents are teachers. My mom is elementary school teacher and my dad is a high school chemistry teacher. So, clearly, my dad has quite a bit of influence on me. That really made me feel comfortable majoring in chemistry in college. Mm-hmm. I have undergraduate in chemistry, PhD in chemistry, postdoc in chemistry.
Sure.
I consider that part of my dad's influence as a chemistry teacher.
So you touched on this already a little bit, but you were chemistry through and through, and then there was this shift to nanomaterials or nanotechnology. And so when did this specialization start to present itself, or what was so interesting about nanotechnology to you at that time?
It was around about 1990s, around the time. Nanotechnology, nanochemistry, nanomaterials, this start to create a lot of excitement. It's a new research field. A new research field presents a lot of opportunity to design, engineer materials in the nanoscale to impact many areas of application and technology. So it's very clear, of course, at the time I didn't have deep understanding, just very shallow feeling. Is we got to go into the new field. I need to look into that. So that's that curiosity, the excitement to get into a new research field just made me jump into nanotechnology right away.
That makes sense. Was there a shift in our scientific capability, like new tooling that was coming out that was enabling us to work at that scale? And let me ask another question too, if I may, which is how small are we talking when we're talking nanotechnology?
If you take a human hair, right? And you look at the diameter of a human hair, roughly about 50 micron, 100 micron, make it easier to estimate, let's say 100 micron. So this means a nanometer is, a hair is about 100,000 times than a 1 nanometer.
Oh my God.
That's how small the nanometer is. 1 nanometer is maybe about 3 atoms across.
Oh my God.
Yeah. That will be about it. There are 3-4 atoms across. And the size scale, how do you design your materials and technology, in that size scale, and just open up new physical and chemical properties. By now, we have a lot more understanding on those new properties. But at the time, certainly new tools available to study in that size scale is important. Some of the tools used at the time, scanning tunneling microscopy, atomic force microscopy, transmission electron microscopy, and plus other tools, right? So you got to have a new set of tools to look at down to atomic scale.
Right. No, that's fabulous. And so you make this shift, and at some point you say, look, Boston is too cold, I'm moving out west to Stanford? Or was there an opportunity here? They said, join the faculty, or what brought you ultimately from the East Coast out to the West Coast?
After Harvard, I spent 4 years doing my PhD. At the time in Boston area, I kept wondering, I say, well, we work very hard on the East Coast. I look at California, how my classmates, undergraduate classmates, some of them come to California. I don't think they work that hard, but they're productive. I got to find out what's going on. I need to come to California to do a postdoc first. That was before Stanford. So from Harvard, I went to UC Berkeley as a postdoc. Spent a couple of years right there and fully immersed into the California system. Really try to understand why. I think I did by now. What amazing environment California is having, including in Bay Area, Berkeley, Stanford. And so after spending a couple of years at Berkeley, I joined the Stanford faculty.
Well, you have insights now from 20 years at Stanford faculty, which I want to ask you about later. But coming from Harvard to Berkeley, what was your immediate impression, or what struck you about the difference in the academic environment between those two institutions?
California has overall very open environment. First of all, people spend more time outdoors than indoors in comparison to the East Coast, right? So then you bump into people so often. One very clear difference I see, the interaction with people is a lot more in California. During my time in Berkeley, now at Stanford. And there's a lot of brainstorming going on in outdoor, in the coffee shop. My favorite spot on campus, right, is the Cooper Cafe, right outside of I-2E2 building.
Yep.
So, a new idea jump out through this casual conversation, and new idea get expanded, get sharpened through this casual conversation. It happened a lot more, I think, at Stanford.
Yeah, no, that makes sense. And I think we would associate the open culture or the nice weather with free-flowing ideas, but wouldn't necessarily reduce it to this very tactical fact, which is, hey, people are outside more, they're having meals with each other, having coffee with each other more. That makes a lot of sense.
Yeah.
But when you first come to Stanford, you're trying to get tenure, right? I mean, that's what all young faculty are doing. And so presumably your first few years were very focused on publication in this area of nanomaterials and nanotechnology, right? So can you describe your first few years at Stanford from a professional perspective?
Yeah, I think you're right. The first few years of tenure track and any young faculty in their careers, they need to be very focused, on what they do, getting the great publication going out, make your name known. And I remember asking my dean of engineering at the time, I asked him, I said, Jim, what are the important criteria to get tenure here at Stanford and engineering school? He told me, he said, there are 3 criteria. Be famous, and be famous. They are the same 3 criteria. I say, yeah, that's it. I got it.
Right.
I got it. So you got to be very focused. And by the same time, as a faculty member, jumping from postdoc position into a faculty position, in retrospect, being a tenure track faculty, it's more like you made the analogy to a company, right? And company has CEO, CTO, and CFO. As a faculty member, you have 3 jobs. You are your own lab CEO, CTO, and CFO.
Right.
You come up with the ideas. You manage your whole lab, mentor your students. You got to raise money. You got 3 jobs to do.
Right. That's hard.
It's not the meaning of CTO. Not only means Chief Technology Officer, also is a Chief Teaching Officer as well.
Right. You've got to teach as well.
Yeah.
Well, was there a paper that you wrote that took you from obscurity to fame, or was it just good publications over time, and then all of a sudden you sort of had this name that you needed to make tenure?
So the first few years, I even though there's a getting tenure thinking in the back of my mind, to be honest, I didn't really think about getting tenure that much. This question, right? I'm more thinking about what impact I can make. What are the problems I should be working on? So this at the time 2005, when I started the faculty position, I move into clean energy technology areas. I asked myself, so to make the global transition into clean energy, what did it take? What does it take? Decarbonizing transportation, super important, right? Mm-hmm. Depending on how you count, this can be 25%, a third of the greenhouse gas emission. It varies between different countries. So electrifying transportation is important. Now the key question becomes, you need a battery technology that could power the car, become electric car, assuming you can decarbonize the electricity source from the electrical grid. And then you need high energy density batteries. You can store a lot more energy at the time compared to the lithium-ion battery technology at the time. So per charge, your driving distance is long enough so you can solve the issues of range anxiety. So that made me look deeper into what's needed to have high energy density batteries. So I invented new materials, and based on silicon anode to replace graphite, about to double the amount of energy you can store in the lithium-ion battery. So offering, at least doubling the range, right? That consideration. But silicon, as a new materials, can store a lot of lithium compared to graphite. Its volume expansion is too big. It causes materials breaking problem. It causes the problem the materials lose contact. The first time you charge up your battery already die. At the time applying nanotechnology, we synthesize materials or silicon materials in form of nanowires to solve that problem as first demonstration using nanotechnology to solve the battery problem with success. My lab published a paper. I consider that was my tenure paper.
Yeah. This
paper using silicon nanowire anode and to solve the breaking problem, to demonstrate the whole world, how the power of nanoscience to help battery research. That become the milestone paper, opening up the whole research field of nanotechnology for battery research. That also become my most cited paper in my whole career, number one cited paper in my 27 years research life.
Yeah, no, that's amazing. Well, and it did make these batteries, you said, twice as energy dense, roughly?
It could lead to up to that, about that level, yeah.
And did I hear correctly that you got some interest from Tesla, even maybe Elon Musk was interested in this paper and had a conversation with you? Or who was seeing that this paper was published and was calling you on the phone or knocking on your door because of this technology?
Yeah, when that paper was published online, the end of 2007, I did receive a lot of calls from venture capitalists, and they come to my office talking to me, encouraging me to start up my company. At the beginning, I was not sure. I was only two and a half years into my faculty career. I didn't have tenure yet, and should I focus on just getting my tenure? doing just research without distraction. And then one day I did receive a call from somebody on the other side of the phone saying he's the CEO of Tesla, Elon Musk. Holy smoke, right? So Elon and I set up a meeting. He come to my office with his team. I remember meeting him for the first time. JB Strauber, JB was the CTO, and his whole team. And we have a discussion on what silicon can do to help boost up the energy density of the batteries for the electric car. That was very early, 2008, and I also got a chance to see the first Tesla car about a week later. So I did a return visit to Tesla and looking at their factory that's in Redwood City. And I was so impressed by what Tesla did, and it's very clear electric car is the future. And also after that, I decided, yes, I probably should be thinking about starting a company, but I certainly didn't know what it means, and I never started a company. It's a lot of complexity right there, and I need to understand. But I decided to do it anyway. So this really set me onto the track of entrepreneurship.
You could see it then, and it seemed like something that you could do too. But why not just license the technology to Tesla? I mean, that is a path that many Stanford academics take, or that OTL often takes. Why start up your own company?
At the beginning, I did explore that. And but through this exploration, I see, because the technology, particularly materials type of technology, invented in university, it's usually very early.
Right.
And if you look at Tesla, right? Tesla taking the cell made by Panasonic, right, to, and maybe Sanyang and others, right, to evaluate that. Tesla was a small startup, and Tesla has no bandwidth to take a new materials technology to develop themselves. It's very clear to me at the time. Of course, now it's very different, right? Tesla has huge amount of resources. Tesla can do anything, right? So I also talked to other companies as well. I mean, the conclusion is similar. And it's very early. It will take a lot to get to the level, become a technology that could be used and the real application in the market. If that's the case, usually it takes the founders, the inventors, really strong faith to say, I believe this is so important. There's many challenges ahead of me, but I'm willing to put in my multiple years of life to be so dedicated to make it into the real world, right? So it took the founders and inventors that dedication and belief to do so. So if technology fall into this category, it will not make sense for a big company to license. Mm-hmm. I don't think anybody, I haven't seen it, will have the same faith to take it to that level.
Right. You need to be almost a little bit crazy, right?
You need to be, exactly.
So do you talk to the Dean of Engineering? Do you talk to your department head? Because you said at this point you're still not tenured, and you're maybe a little nervous about splitting your attention in multiple ways. So talk me through that thought process.
I did. I did talk to my department chair. I talked to my dean. I actually also have a chance to talk to president of Stanford as well. The feedback is mixed, which I completely understand. Mm. One voice is, hey, you don't have tenure yet, focus on tenure. Another voice is that I think you're doing well. You decide for yourself whether you want to start or not. I appreciate both type of advices. I listen to my internal voice and say, I should start a company.
Okay, yeah. And so you do, right?
So I did, yeah.
And so talk me through how you approach that, because as you said, you're an academic. You've written this paper. It makes a bit of a splash, and now you're starting a company, but it's not like you've started 3 companies before. you are at Stanford, which is a place that has a lot of people and resources for those who start technology. But I imagine that those resources are not as significantly built out as they are today. So who do you call? Who do you talk to? How do you get advice as to how to be the founder of a startup?
Yeah, the first thing I got to do is talk to an attorney.
Oh, yeah.
So I did, and talking to a partner in Wilson Sonsini, well known in Silicon Valley, right, for startup world. I learned so much from this partner to educate me, how to think about company structure, and how is the share structure look like, how do you think about the board, right? The management team and so on, just everything. Mm-hmm. So it's a lot of learning. Right? If you look at the legal term, hey, Sam, you're a lawyer. I mean, you guys make things very rigorous, at the same time very complicated.
It's just
in a good way.
It's for job security. It doesn't need to be that complicated. Yeah.
So just to understand what it means, or each term, right? I mean, I just by the time I signed that dotted line, I think I understand maybe 60-70% of what it means of that legal term. Sure. I have no appreciation what it means in the future. Right. But I had a good faith on what my attorney advised me. I think it was amazing. Making a great suggestion to me. Now I look back after more than about 17 years, right? So. And those terms still makes a lot of sense.
They're good, yeah.
For me to sign the dotted line, yeah.
Well, public service announcement to talk to a lawyer early on then.
Yeah, absolutely. I think people need to understand this. Talking to a lawyer, actually a lawyer is not just legal advice right there. Actually, a great attorney help you to think through. It's a legal plus business together. I mean, it's just incredible, the advice I got from Mike Danaher. He's the partner in Wilson Sonsini. Just incredible. He's an amazing person.
That's awesome. Terrific. Well, and you're also getting advice presumably from other people at Stanford and from investors who you raise money from. So maybe you can speak a little bit about how you did your first fundraise and how you brought that early executive team around you.
The fundraising part is, this whole world is very complex. And I think one needs to learn as a faculty is you learn a little bit from someone, but you learn a little bit from so many people, and then you put the pieces together, you kind of form the full picture. That's right. My advice. Because everybody coming in talking to you in the investment world have their own interests.
Yes.
Yeah. So then you need to put the pieces together. That's what I learned. But I did meet with some really good investors, great people. One of the investors I'm super impressed. He's the chairman of Amprius. I started Amprius, right? That's the first startup taking the silicon nanowire anode, silicon anode technology to the real world. And Don Dixon from Trident Capital, I think it's still called Trident. Yeah, maybe he changed name. And Don is just an incredible investor. And I really love how he did things. He said he would treat people the way as like he's going to see these people for the rest of his life.
Yeah.
Treat people fairly.
Yeah. Well, and that's powerful advice here because the Bay Area and Silicon Valley is small.
Yeah.
The tech industry is small. And you do see the same people over and over again for the rest of your life.
That's right. And also, I think different investors, the style is so different, right? Hands-on, hands-off. Entrepreneur need to digest that. Is it good or is it not so good? And I have my own thought, right? So I think you got a mixture of investors.
Sure.
And you get hands-on investors right there. The contribution is gigantic. Maybe you don't like it as much at the beginning. Then if they create huge value right there, I think you should embrace it.
Yeah.
You have some investors completely hands-off, which is fine. And you probably need a mixture. If you have too many investors all hands-on, then this becomes crazy for you to handle.
True. Well, you make it through to a successful exit with this company, right? I mean, the company goes public. And so my question to you is, along that path, What was the high point or what was a low point that you'd like to share out? The worst of the worst or the best of the best?
By the way, startup world, the high point is so few, but low point are a lot.
Yeah, right.
That's a norm. A lot of low points,
Yeah.
very few high points. So that's experience. But speaking of Amprius taking to the public, very, very important factor right there. Very important people are the executive team, particularly CEO. I cannot emphasize enough how important a great CEO would be. Make or break, CEO is super, super important. I was fortunate to have Kang Sun. Kang is still leading Amprius in the public market, right? Just incredible CEO.
How did you get connected originally? How did you make that CEO hire?
We have a search firm, search for the CEO. So I talked to a number of candidates and the whole board talking to a number of candidates. I mean, for my first company, I really has very little judgment what good CEO really means, right? How does a good CEO will look like? Not until I talked to Kang. And first meeting, I just say, holy smoke, this is the guy.
Right.
He shows up, different from anybody else I have been talking to, and that's it. It's him. When you see it, then you know it.
You know what it is, yeah. Well, now that you've worked with him for so long, like what is it that you think sets him apart, or what qualities do you look for in a CEO?
Well, actually, a great CEO knows nearly step by step how do you take from beginning until the end. At least he has a few versions of that. He can see through this. I mean, this is built on the CEO's past experience. Before coming to Amprius, he has taken solar company to public before, from beginning to the end. And in academia, what I call this, when I hire a student, or particularly postdoc, students are okay because the students are young. If this postdoc haven't published great papers yet, that tells you very likely he or she doesn't know. If this person have done it a number of times, that's meaning a lot. Track record means a lot. Then what about people without track record? Then the risk you're taking is becoming higher. Then you need to form, really good judgment. Is this person a real entrepreneur or not? So what does entrepreneur means? What's the spirit right there, right? So, and you need to evaluate this person, this multiple aspect of that. You need to put this person into that different lens to evaluate.
I want to shift from Amprius over back to your academic career because you've started this company and the CEO comes in to run the day-to-day and build the team and do a lot of the product development work, although I'm sure you're still very, very involved. But when was the moment that you gained tenure and started your lab at Stanford or maybe received some academic startup funding? Because you must have been doing this at the same time.
When I come to Stanford, right, so I to start my own lab, this startup funding right away.
They gave it right away?
Yeah, right away to start my own lab. So getting tenure is just getting tenure to stay.
Okay.
There's no new startup money coming into my lab.
Sure.
So, and it's just recognition I could stay at Stanford for as long as I like.
As long as you can continue to raise grant funding to fund your lab.
Yes.
Yeah. So the experience though with the company, I mean, you're a young faculty member and you have this company on the side. Many faculty at Stanford are interested in the private sector, but many are focused purely on their research. So how do you think that this experience of running this company, Amprius, and having it be a success then informed what you were doing in the lab? Like, why was it helpful to you in your academic career?
So Sam, this is a great question. So after I started Amprius, I started to see many problems company is facing. They have a deep root back to fundamental and applied research. Those questions, those problems are highly valuable for academia to work on. So I can see many problems because of my involvement in the startup. This is problem coming from industry, feedback into Stanford, into my research lab. Then I work on those problems, solve those problems for the benefit of the whole world, not just for my own startup company. Turned out to be this way, and my colleagues in other institutions working in the same research field keep asking me the question, how come you come up with so many problems? After you work on those, other people also recognize that's a problem. They also work on following you. I said, because I have fast feedback, I can see the problem from industry. This speaks for the value of academia, industry, information, at least questions flow is so valuable. That becomes amazing academia problem to work on. I love to encourage you more at Stanford, actually, for all the institutions around the world to do so, right? But certainly, I also respect my colleagues, even they don't have industry, connection. They work on the problem they are interested in. That's fine also, because academia should be able to allow multiple approaches, methodologies coexist on the same campus.
No, that makes a lot of sense. Well, the company does well, your lab starts to take off. I mean, you start to have many, many graduate students working on technologies because you're working on many problems. So maybe just for the listener or the viewer, could you put into a sense of scale your academic lab in this time and maybe over the first 10 years? Like it goes from maybe a few graduate students to many more, right?
First year, 5 people, 4 PhD plus 1 postdoc, about 5. And then second year becomes 9 people. Third year becomes 15. And then it jumped to 35 right away. And after 3 years, right? And then stay at 35, 40, 45, sometimes get to 50 people.
Yeah.
For the past, 15 years roughly. So you stay at that size, let's say 40-ish people.
That's incredible. And I mean, like you said, you're the CEO, the CTO, and the CFO of your lab. And I imagine that you have a lot of learning along the way. And what role are you playing at Amprius while Amprius is being built? Are you the chief scientific advisor? Are you on the board? Like, how does this work?
2 functions, chief scientific advisor as well as board members. I stay in the board until Amprius went for public 3 years ago. So for the first roughly about close to 10 years, I was quite involved with the Amprius. And after roughly 10 years, I'm still involved, but involvement reduced because Amprius is going up a lot. So, I started to, after about 10 years, spend some of my time to start my second company, third company, fourth company until now, yeah.
Right. I know we've spent a lot of time with Amprius, but it's an important first step. I'm curious too, I imagine that your experience with Amprius and management of that fast-growing startup helped inform your lab and management of your lab. In other words, maybe if you didn't have a startup company, it would have been difficult to scale your lab from 5 students to 40 students within just a few years.
Actually, the management part of that, I think the influence is less. My lab grew bigger first before Amprius grow big.
Got it.
So yeah, my lab grew to 35 very fast. It's actually before Amprius. I think the managing so many people, like having a big research lab, really come from during my PhD and postdoc. The 2 labs I was in, like 1 PhD, 1 postdoc lab. They are all big labs. I used to see big lab. I know how the big lab will be run. And some people ask me, you're running such a big lab, it must be really hard. I actually have a counter argument. Running small lab is much harder than big lab.
Interesting. How so?
Because a small lab, let's say if you have 5 people lab, and 1 person leaving is 20% of change. If I have 50 people lab, 5 people leaving is 10% of change. Yeah. Actually, that fluctuation, not easy to manage if fluctuation percentage is big, because there's certain expertise you need to keep. Mm-hmm. Once you have more people right there, 1 person leaving, expertise still there, continuity is there. I think running big lab is the financial burden is is, of course, you need to overcome. But in terms of maintaining a coherent research program, a bigger size lab is easier than a small size lab. And bigger size lab, people learn from each other. You have a lot of expertise developed internally. Younger students learn from the more senior students. Students learn from postdoc. And there's a lot of mutual learning. Supporting system is stronger inside one lab.
How do you help the students and the postdocs find really good problems and questions, right? I mean, how do you give this advice? You very clearly were focused on impact, and impact was overlapping or intersecting with the clean tech revolution or with this climate and sustainability revolution. You have this experience in industry. You also have your independent research projects. So you have a lot of visibility into the world, and you have a strong sense of the kind of impact that you want to have. How do you instill that in your students, or do you let them find their own way, or a mix of the two?
Most of the time, no, it's not the students. Most of the time, it comes from me, particularly the early 15 years, first 15 years of research. I was exposed to many society technology application problems. When I come to Stanford, I started to open up a new way of funding problem. It's really coming from society. I need to analyze. Clean energy transition is very clear. What do I need to do to analyze each area deeply, and then that some research problems start to show up, and that can come back design into a PhD thesis, a master thesis, right? And also talking to industry, understand what's their pain points right there. This feed you a lot of problem. So this problem really can come back as a research problem in academia. So it's usually, when graduate student and postdoc joining my lab is me giving them the idea. The recent 5 years changed slightly. I took more of the administrative job at Stanford. And the time bandwidth is limited, so that freedom, I shouldn't call it freedom, that getting students, to chip in more of their idea just become more and more. But oftentimes it's me. I love to sit down with a student when they just join in my lab, start to talk for 30 minutes brainstorming, and I like the style before students walking into my office. We don't know. I don't know what problem they should be working. I start to talk, asking about students' background, to see their interests, and then 20, 30 minutes later, I might come out an idea and say, hey, what do you think about this idea? And they start to work on it. Yeah.
And you've had many students go on to be faculty elsewhere, right? I mean, how many students are now professors at other institutions or even at Stanford?
I developed roughly about 140 PhD distributed globally outside. Close to 100 of them are professors.
That's amazing.
It's about 95, I think close to 100 by the end of 2026, yeah.
You'll have to throw a party when you get to 100.
Yeah. Well, I like to throw party all the time. So I already have a few big parties to celebrate my 20 years at Stanford. So
that's right. Yeah, that's right. We talked a lot about your early career, which I think was important. You go on to start a few more companies, and we can mention anything you want to mention about them. But I am interested in getting us to your current roles for Ecopreneurship and the accelerator, the Sustainability Accelerator. So the year is, 4 or 5 years ago, Stanford receives a big grant to start a sustainability school. How are those early conversations being shaped? Who's in the room? How are you getting tapped to set up these programs? Can you sort of paint a picture for how this was all coming together, both for Ecopreneurship and the Sustainability Accelerator?
Yeah, well, setting up the new school of sustainability, it took longer time than just a few years. And the Doerr School of Sustainability started and launched in 2022. And 5 years before that, the planning started, I think 5 years before the school launch. So 2017, when you look at that, right? So 2017, I think this long-range planning at Stanford. So this long-range planning and collect all the ideas from faculty, what Stanford should be working on. Big idea. The idea of working on climate change, sustainability, really bubble up among many faculty and staff suggestions. So it is long-range planning, long-time planning to lead to the formation of school. And this vision of setting up whole school to tackle sustainability problem and really resonate well with John and Ann Doerr. And John and Ann and their team and come to Stanford to do a lot of conversation, due diligence, how to really understand Stanford's commitment, Stanford's plan to set up this new school. They were very impressed. That really motivated them to make this major gift and to have a school behind sustainability to solve this challenge. There's many faculties involved during that process, to have very active dialogue, communication, discussion with the Doerr and the Doerr's team. It was very, very exciting to see the commitment from the Doerr family. They certainly provide a lot of advice after the school established, a lot of advice for our build-up of the whole school. Highly valuable.
And so there's early long-range planning that happens in 2017. The gift comes later. The Doerr School gets going, and all of a sudden there's a research prerogative. There are buildings that need to be renamed. There's all sorts of stuff that has to happen. But one of the key pillars of the Doerr School is this idea of impact and having it be directly useful, and directly useful very quickly, right? Because climate change is a problem that is happening now, and it's happening fast. So there's this entrepreneurship pillar. And maybe you could speak a little bit to the Accelerator program and your role in that program.
One very important idea, different from before, is to focus as one of the pillars of solution generation. How to generate solutions to impact the real world, in addition to knowledge creation. We know academia, for such a long time, we emphasize knowledge creation and pass to students, right? This continue, of course, to be one major pillar. But now in the Doerr School, there's another pillar we are building up. We want to change the culture a little bit, at Stanford, is the solution generation. Not only develop the solution, also to launch the solution into the real world. So I emphasize develop and launch. If you only develop without doing launching, then the impact is reduced tremendously. That's where Sustainability Accelerator comes in, is to identify important areas we call flagship destination. What are the important areas? You need to make scalable impact, global impact. We emphasize scale. And come back and analyze what are the gaps. Is it technology? Is it policy? Is it market? Is it social behavior? Then how do we change that? What solution can we develop? So we define a topical area in the accelerator, let faculty, students propose what are the solutions they could generate. And going through the selection process with the scale in mind, need to have scalable impact. So we pick the project, we select the project, we fund the project, help the faculty in a way, we build an ecosystem for faculty to interact both internally, also with external partners, investors, nonprofit, government. And after developing this idea successfully and launch into the solution, this launching could mean it can be startup companies, it could be nonprofit organization, it could be one piece of legislature, and to form a law, right? It could be something that can help changing social behavior. We endorse all the idea that could make impact. So this way, defining the final destination first with scale in mind, come back to do research, solution development, and launching. Is this whole full circle is the heart of the accelerator.
Yeah.
Is the impact-driven, solution-driven mentality we bring into the whole Doerr School of Sustainability. We bring it into the whole Stanford campus. And it's super exciting in the past couple of years to see the impact we already made on our faculty, on launching solutions. I will predict the accelerator model we are running is going to be very successful.
That's amazing to hear. I want to ask about policy solutions and social behaviors among other types of non-technology solutions, because we at Stanford think of technology companies. And many of the other faculty that we're talking with on this podcast are founding technology companies. They're at the forefront of their field. As you noted, I'm a lawyer by background, and so I'm really interested to hear about policy solutions, and you're talking about social behavior solutions. What form might that take? I mean, the accelerator, I imagine, you're not just going to write a statute in a vacuum and then email it to a legislator and say, you should adopt this. Like, how are you working with actual legislatures to make sure that laws are well designed? Or how are you impacting social behaviors? What does that look like?
Even for technology company, they go to scale of technology, right? It's nearly guaranteed there got to be a policy right there. Otherwise, scaling technology is very, very challenging. So first of all, I see technology scaling means you got to have the right policy framework right there. Otherwise, it's very hard. Scaling is not just one nation, it's across the border, it's global. So policy is super important. So this is something we are learning, what does it mean to have policy solution going out? Start from the example. First is Michael Walras, the Wi-Fi policy Mike is working on, try to influence a California legislation, and this has quite a bit of success. And policy, you cannot work in vacuum. Almost right from the beginning, designing that policy need to involve in existing stakeholders, external stakeholders, to be part of it. And then once the policy is designed, you need those people, external people, to help implement. So that's why the whole accelerator is both technology and policy. We emphasize, if you propose an idea, we ask the question, who are your external partners to have external impact right from the beginning when you write proposal?
Right.
I think policy is a perfect area. You got to have external partners. I mean, from government, right? From Congress, maybe it's the staff member in a certain congresswoman's office, or previous, administrator. They understand the policy challenges right there, or people they are about to go into office, to do the service. So we got to, partner with outside to do that.
And as far as Michael Walras' work with wildfires, that's localized to California, I imagine, even though it probably will want to be modeled in the broader American West. Are there examples of policy initiatives that are at the federal level or maybe even in an international jurisdiction, or are those yet to come?
Those are yet to come. And this is now using the podcast, I want to advertise, right? So we want to do more in the policy areas. Yeah. We understand the challenges and we want to do more. And I hope audience listen to this and say, hey, I love to partner with Accelerator and reach out to us.
Terrific. The Accelerator, thank you for giving a bit of background, by the way, on the Accelerator. I think it's a phenomenal initiative. There's another similar but different initiative that you're involved in called Ecopreneurship here at Stanford. So would you give a little bit of background on that?
We were lucky to have Mark Benioff from Salesforce, right, to make the skip to set up Ecopreneurship program. Well, from the name, no surprise, is eco and entrepreneurship together, merge together as one word. Idea is try to develop graduate student, undergraduate student, postdoc, like this whole category of students to become future entrepreneur and sustainability space and the whole ecosystem, right? So this is complementary to Sustainability Accelerator. And we know we need young people coming in, young people full of new ideas, very, very dynamic, energetic. We want to really harvest the excitement and from large number of students to get into sustainability space. So in Ecopreneurship, and this we set up the program and in multiple levels, on multiple areas to help students. In the general area is education. To educate students to become entrepreneurs in sustainability space. We've been supporting faculties and staff members teaching classes, entrepreneur classes related to sustainability in the order of, neighborhood of 10 classes or something we are supporting. It's also an opportunity to have so many entrepreneur classes together at the whole Stanford campus. Stanford is big. Classes in different schools. Put them into the same place with visibility to students. Help them to plan what classes to take. So that's one type of impact. That's first. And the second one is getting into, and after you do have the general education, and entrepreneurship for sustainability, some students will become very serious getting into project level. Right? There's the detailed project for you to evaluate a technology and do a business case out of that. Right? For example, Stanford Climate Venture is one of this class, right? So to help students really using a detailed technology areas, the problem areas to develop students postdoc deeper into the area. And then there's the next level of opportunity we offer is, you really want to see how startup work. We support you to work in a startup company, right? To go experience that, during the summer into that level. And then we have next level is you want to become entrepreneur, you have an idea, you want to work on, right? We support you to think about starting our company and give you a year of support. So we have the full scope in Ecopreneurship.
Well, I even noticed this on campus with all of the students that I interact with as far as the Ecopreneurship program, because there is so much excitement. There are so many students taking Ecopreneur-related classes and starting companies. And we at the law school benefit from working with them in my class, Startup Law Sustainability, where we can provide pro bono legal counsel to these students. So thank you again for just creating this network of folks and knowledge.
No. I need to thank you. And you've been a playbook, entrepreneur playbook for faculty and students to look at. This provide a lot of guidelines for students, faculty to think about entrepreneurship. And super valuable, right? This playbook is, as the first book we now, send to our faculty and say, take a look at this.
It's great news.
So let me also emphasize this through this process, right? So it's a nice collaboration between Ecopreneurship from business school and the Doerr School of Sustainability. We get the attention from the both deans. We have 2 faculty co-directors. I'm from Doerr School, Stefano from business school, Keegan is running that. We have amazing team right here. Now with you in law school, right? So this become
all-star team.
I couldn't predict, just automatically flow so well. Sure. And that's why I say, at Stanford right here, when we start something important, we can serve the whole university. We don't limit to one school.
Right.
And we serve the whole campus. When we can have input from other schools, make it better, we will get the input. We work together. Right. I mean, in this case, it's law, business, and Doerr, all flow really well.
Well, thank you so much for coming in. It was really a pleasure to talk with you. I learned a lot.
Thank you, Sam.